In this video, we start on page 6 of day 2. The population of a town is given by this P of t function. This is an exponential function, you see, has a y-intercept of 85.2, and it's got a factor of 0.924, so it must be a decreasing function because the factor is between 0 and 1. This function is a model. It tells us that t is the number of years after 1950. P of t is the population of the town in thousands. So part A asks us to first just write the interval from 0 to 70 in interval notation. Now notice it does say less than or equal to and less than or equal to. So when we write it in interval notation, t can be greater than or equal to 0, and it is less than or equal to 70. So we're going to use brackets on our interval notation because it can equal those endpoints. And it says to write the real-world contextual meaning of this interval. T represents the number of years after 1950. So 0 here represents 0 years after 1950. It's saying from the year 1950, that'd be 0 years after 1950, up to 70 years after 1950. So that would be the year 2020. It's saying that we should only consider this P of t function from the year 1950 up until the year 2020. Graph the function from the year 1950 up to 1920. Now you can do this on Excel, or you could do this with the help of graphing calculator, or you could try to just sketch it by hand. To graph it, I'm going to graph it from t equals 0, which represents 1950, up until t equals 70, which represents the year 2020. T is along the horizontal axis representing years since 1950. I label that axis with the letter T, and I label it with the meaning of that variable T. The vertical axis is P of T, and I'm going to go ahead and graph it from a low of 0, population 0, up to the high value. I'm going to start with that y-intercept, 0, 85.2. So this is a decreasing exponential function. Looks roughly like this. Starts up here on the y-axis at a height of 85.2. It's decreasing concave up, so it looks like this. Is this function increasing or decreasing? And I know it's decreasing because, again, that factor, 0.924, is between 0 and 1. And the real world meaning of this, so I'm going to write this in two ways. The factor is 0.924. That literally means every year the population is 92.4% of the previous year. Another way to interpret the real world meaning of this is to say it in terms of a rate, a percentage rate of decrease every year. Now remember, in an exponential function, factor equals 1 plus rate, the percentage rate. Or you could say factor minus 1 is equal to the percentage rate. So in this case, 0.924 minus 1 is your percent rate, which in this case is negative 0.076 or negative 7.6%. It's saying every year the population decreases by 7.6%. So this means that there's a large population decrease in the early years, but only a small amount of population decrease per year in later years. Large decrease here in the first year, large decrease in the second year. But as the years go by, the amount of decrease is a smaller number of people. So again, each year that goes by, the population decreases a smaller and smaller number of people. Now, let's just put a couple numbers with that just to make sure we're really clear. In year 0, this function would output 85.2. So in 1950, there are 85.2 2,000 people in the town. Now, if you plug 1 into the function, you'll see that the output is 78.725 approximately. So after 1 year, so in 1951, there's 78,725 people. So a pretty big decrease. Now, if you plug in 69 into the function, you'll get out 0.3646. So it's saying in, that would be 2019, there are 365 people in the town. And then if you go one more year to 1970, it outputs 0.3113. So in 1970, there's only 311 people in the town. Now notice the amount of decrease there went from 365 people down to 311. That's not that big of a decrease. Whereas before, it was 85,000 people down to like 78,000 people. That's a big decrease. So each year that goes by, there's a smaller and smaller number of people leaving town. All right, and lastly, identify the right tail behavior of the function. And decreasing exponential function will decrease down and get closer and closer and closer to the x-axis. The function is getting closer and closer to a height of y equals 0. So it's approaching y equals 0. The p of t value is approaching 0 as the t diverges up to infinity. So this is saying as the years go by, the population is getting closer and closer to 0.